we're going to get through this the best we can. So as the introduction, we already explained, look, we were really looking for new talks. This is where you can help. I have to tell you, even now, after I've been involved with BayPiggies all of these years in other Python groups, every time I give a talk, I learn something. And I learned something very significant during a peer review when I asked Jeff, hey, Jeff, can you help me just proofread this? And Jeff pointed out something. See, sometimes I have old timer brain where I'm thinking of things from a long time ago. I'm thinking of things where, Python dictionaries were not necessarily ordered. Well, that's changed. And in my mind, I'm like, well, what about the other versions? Yeah, those old versions are not deprecated. It's not supported. It has really changed for everyone. Oh, I don't have to think about that. Every time I give a talk, I learn something. And if you wanted to give a talk, even a newbie nugget like this, you would learn something because you think this would be easy. And then you start preparing everything. And then you're like, oh my, there's a lot more here that I need. And then you start going through all of it. And then soon, before you know it, you actually have learned something and you have a talk. And afterwards, you feel really good that you've leveled up. I once gave a talk on something called South, which later became part of Django. And I remember at the time when I looked in the front row, it was like, oh, there's Alex Mortelli. There's Guido Mortelli, Guido van Rossum. There's like everybody I could see like was really like had written the Python language. I was super nervous. They probably don't remember that I was super nervous, but at the same time, I learned a lot about it and it's now built into Django, which made me even stronger. So I encourage you to contact Jeff and say, hey, I want to do a newbie nugget. No talk can be too small. All right, so thank you for correcting that link, Jeff. That's awesome. All right, so basically, this is why we're going to have a talk, and having these data formats is actually going to be really important. I didn't have time to make slides, so we're just going to go through this link ourselves together. And these kind of formats are very important if I want to have this program communicate with that program to communicate with another program. And we're just going to talk about them briefly. We're going to talk about their strengths and the weaknesses, and then we're going to dive into some examples. All right, and we're just going to use some example data. This is my data. So yes, I'm putting a lot out there. Because this is recorded and out there, I did remove 2 fields that are not real. Any guesses on what those are? Put them in chat. You might be right. We don't have awards that I can give you one, but if you get them right, I'll say you're right. But 2 fields are made up. The rest of them are real. So we're going to use this real data. Yep, street address is one of them. We're going to use this data, and we're going to try to map that and model into something else. And the phone number is also fake. So that means that Bitcoin address is correct. You can test it by sending me 1 million Bitcoin. I'm kidding. That's fine. All right. So back to the strengths and weaknesses. So we're going to look at 3 of these things: JSON and YAML and XML. And if it's confusing on how many there are, which one to use, why are they 3? If I can represent everything in Python right above, then why do I have a different way of representing it in JSON, a different way of representing it in YAML, and a different way of representing it in XML? And my way of breaking that down is, look, JSON's for programmers and APIs. YAML is for people, and you'll know what I mean by that in a little bit. And XML is for computers. Now you might say, wait, programmers are people? Yes, that's true. But I'm really talking about something specific when I say programmers and APIs, and it's really for the API part. So as we go through this, hold on, there's something in my way. I've got to move the participants. Okay, good. If you've given a choice of a format, if I were to come up to you and say, look, give me something, I don't want to learn all 3 of these, which one would I use? I would say, if in doubt, if you're interacting with another service, use JSON. Avoid XML if possible, and we'll see why when we get down. It works, and there's some things that are there, but JSON's a lot easier. And if you're actually integrating with another system, then we're going to use, like if you're actually going to be a user trying to type something into another system, that would be better for YAML. And we'll see that in a few moments. All right, so here's the Python representation of the same data. So same thing we saw again. We don't need to go too long. It's a dictionary, real nice and easy. And like I said, JSON was for programmers. So we're going to start there. And JSON is the acronym JavaScript Object Notation. Wait, JavaScript? Wait, what? Yeah, JavaScript notation, it was actually formalized very early on. So even though it looks almost exactly like a Python dictionary, it's a formal structure. It's really a string that fits this structure. And if you can save it to a file, and if it's the structure, you can have it in a string in memory if it's this structure, and you can parse it so it actually parses into Python dictionaries or whatever language you have. Because it's already formalized and there's a really clear standard on it, it's a great one, even though it comes out of what's called a JavaScript object, which really looks like a Python dictionary. It really is just almost the same thing. But even though it's a subset of JavaScript, again, it maps perfectly well. So here's that same data, just to show you how well that maps as JSON data. First name, surname, you could hardly see the difference here from what a Python dictionary is. So pretty much that kind of makes that point for us. How are we going to bring the JSON file into Python then? So we're going to do, this is a library inside of Python. So we're going to import JSON to use it. And there's a method on that called loads. So really all you have to do is import JSON. Now, obviously that data in this example is a string in memory, but you could have loaded it from a file as a string in memory. But this data is a string that then gets interpreted as a Python dictionary. And then if you wanted to go look at this example, and we can go dig and look at those in a few moments if we want, we can actually see how that actually pulls that information in and reads the JSON source file. And I'll hold off looking at those a little bit later just so we can do the overview first. Excuse me, sorry. So we'll do the overview first and then we'll come back into it. Now, what if I wanted to go the other way? Look, I'm going to convert Python data to JSON. Well, again, we just import that JSON module, but now the method is dumps. So I'm going to take a Python dictionary and I'm going to dumps that Python dictionary into a string or a file that represents JSON data. And we'll see that there's a to.json example that's coming up as well. And again, it is a standard, so that makes it really, really easy. Why? Why do we care about this? You said this for APIs. Show me an example. Great. This particular repo itself actually has an example in it. So if I want to just, use curl or find some other way to read this information from online and pull it down, guess what it is? That happens to be JSON data. Notice that this is a commit object. I do a class in Git and Git training and Git internal, so talk about how Git works and heads, refs, and objects and how to really understand Git to make it your friend instead of something that's confusing. And we can tell that just means it's a Git object right here that's built into the internals. It's a hash. It's where your commit basically is stored. So you'll notice that is the same information represented in JSON data that I pulled from the API by just doing the curl. And I've snipped it. It's only a small bit of information here and a lot more easy to parse. For example, like inside of a commit object, there's a tree object. It's automatically parsing that out and showing it to you. Like for example, if I were to take the same thing and I were to use Git to dump the internals of that particular hash, I would see the things, the tree object, like I just mentioned. I would see the parent, that's what commit was previous that I'm linking to, so you can have your Git log and chains. And then the same author information you saw, a timestamp. The committer information you saw in the timestamp happened to be that those are slightly different because I did a little tweak on that one before I finally finished it. Signatures are not normally there, but that's a GPG signature, and then the actual message at the end of it as well. So you see there's a lot of info there. I think I snipped off the actual Git message on that one, so my apologies on that one. I'll go fix that. So that's kind of the high level overview of why we would use JSON. JSON's great for interacting with APIs. You can use XML to interact with APIs as well. JSON really is closer to understand and to get your head around. It's a lot like Python dictionary if you're used to it. And you can interact with web APIs and pretty much rule the world at that point when it comes to everything that comes to interacting with a million systems. If that's written in Java, I can still interact with it by using a query and consuming the JSON data. I can write the JSON data and that Java app can consume it. Same as Go or anything else. So it really allows lots of separation of systems. Okay, so that's 1/3 of what we're doing. 3 different talks. The first was 3 different data structures or different ways of representing data. The first was JSON, now YAML, and then we'll get into XML. So for YAML, I actually said that YAML was for people. And you're like, well, I don't understand what you mean by that. I'm a programmer and I'm a person. Yes, that's true. And I'll explain that in just a second. The original acronym for YAML was yet another markup language, but it kind of outgrew being a markup language. So just instead of having to change the name and confuse things, people just said, you know what? Now it means this recursive algorithm, just like GNU, it means YAML ain't a markup language. So I think a little bit of a force on that one. But basically, YAML is actually just like an outline. It's the same representation of a data in an outline. In fact, here's an example that you would see for Ansible. A lot of different systems will consume this YAML input. Ansible is a pretty big system you use that helps you say, I'm going to take this system that's right there, that is just a bare metal, like I just installed the OS and not much else. And then I'm going to say, apply all of these different things to that particular machine and make it a web server so I don't have to touch it by hand, so that I can have a lot of code at scale and I can just push things out and auto scale and have 15 web servers all at once, delete 3 more, make 2 more. It's all done because it's represented in computers. And you can also describe that very easily in a YAML file. So here's an example of that YAML file and that YAML syntax. We're saying what host. This is relating to an inventory file that says all the web servers that are linked, all the hosts that are linked to and called web servers. Those are the ones I want to apply this to. What variables are going to be related to this particular playbook or this particular YAML file that I'm talking about? In this case, we're going to say the number of Unicorn workers are 3. The DNS domain is going to be example.com. And we're going to say it's only supported on these distributions. There's some kind of reason we decided not to support more. And I might say, before you do anything else, just make sure that you've populated service facts or have a pre-step. And then now this host should act like a Django server, be a Postgres client, have the static files already collected, just like you do in Django. Migrate all of the system databases, like all the Django migrations, get the Gunicorn system unit up and down so that Gunicorn is representing and basically serving that data linked to Nginx, which is an Nginx server. So in that amount of YAML, I can specify that on a system, assuming I've written these, which I have and which I've not shown you, in a very idempotent way. Then I can actually say this YAML represents that host. And the good thing about this is that I can take it to anybody who's a manager who may not be technical, or someone else who's a QA person, and they can say, oh, no, these web servers are not supposed to have this one anymore. They're supposed to have that one. It's so easy to consume because it looks like an outline that people, and that's what I mean by people, not necessarily programmers, can still interpret it. And so that's what I mean. It's the intent is like to specify this configuration file. And but like anything, because this actually represents data, clearly if I was a human and I forgot to put my little bullet point there, my little dash there, it would make sense to me as a human as an outline. But of course that wouldn't parse, and then there would be a YAML error because it's actually not valid YAML to have it mixed like that. So it's a little bit of fiddly in those places. So you need to know, all right, here's the thing that people get confused by. When is it a list and when is it a hash dictionary? And so in this particular case, it's a list because just like you see these little items, that means it's a list. Each one of those means, you know what? It's a list, and it just means that roles : this would actually be the same thing if I were to write roles : / open bracket, Django web server, comma, Postgres client, comma, just like right up here. So this in supported distributions could have been rewritten so it came on the next line and have dashes. So if it has a dash like that, it means it's a list. If it doesn't, if that were not to have a list, that would have been a dictionary. So if I were to have a dictionary, then this would actually be the dictionary, and those would be the values that would be represented inside of that. I'll show you an example. Here in the address, this particular address actually has a dictionary. It has kind of like a name, and inside of it, instead of having something else, it has a key and it has a value. It has a key and has a value. Has a key and has a value. So this really is a dictionary, even though it looks like an outline. And really that translates very much like we just saw a second ago, is here's the key for the main one, and this is a sub-dictionary right inside of that. All right, so I think I just explained everything that we just saw with the caveats. Let's talk about how to bring this into Python. They're just like with Json. This was a built-in. Json was built into built into Python itself. So all you have to do is just import Json. But YAML isn't. We have to actually have two external libraries, and there's two of them. One's called PyYaml, and this actual one, I've never actually said this aloud. I didn't realize till now I'd have to practice doing so. Ruamel.yaml, I actually don't know how to say that aloud. I learned something new from this tech talk. If anybody knows how to pronounce that, go ahead and say it here. This is the more current one. This is the one that actually is being built on. PyYaml had a couple of really disastrous bugs, very big security holes, and some things that weren't being fixed. It's just they just didn't get the, like a lot of us as open source projects, we get busy. So sometimes we just stop working on things, or we don't have time to finish working on it. So there's some actual open bugs that are still in PyYaml that are not being fixed. And this project took that over. And actually, even those open bugs, a lot of them at least, that are still not fixed but listed inside of this project, have been picked up and fixed here. So if it were me, I would pick this particular project. All right. And so in this particular case, I would say, look, from that project, import YAML class. And in that class, we are going to basically instantiate it with two arguments. This, if I couldn't highlight anything else from this talk, this is the most important. Right here. Make sure that you do a safe import for those security reasons I mentioned earlier. And then I also give it an argument of true. Oops, I think questions might be coming in. Might have missed that. Sorry if I missed a question. Jeff, someone interrupt if I missed anything. All right, so, all right, good. I just maybe saw a difference of attendees. All right, so that actually means it's got to be safely parsed. Otherwise, you can have a pretty bad CVE, which I'll mention down here. But we open the file and we read it. YAML.load, and here's the thing. When things are written by different people, it can be confusing. Is it load or loads? For Json, it's loads. For YAML, it's load. Is it dump or dumps? For Json, it's dumps, but for YAML, it's dump. So one of those things we just have to stick in our head because it was written by someone else. And I think load and dump make more sense, but for whatever reason, Json was written with the plural, and that's just the way it is.
Does Jeff comment on that? I think there is a load and dump in JSON. The difference is the S is for string, and the load is for a file object.
Whoever said that, I owe you a meal at our next time we see things in real life. I will find that afterwards. See, I learned something from every talk as well. So this is like the third thing that I've learned from doing a talk. And this is why everyone else should do a talk too. Just be brave, do it, you'll learn a lot, and it'll help the community as well. Yeah, dump S for dump string. That'll always stick in my mind now, mostly because I just realized it now in front of an audience, but it's always gonna stick in my mind. Dump and load are always what you're going to use, but if I'm taking a string, which is what I was doing in the example before, it's actually load string and dump string. So perfect. So it actually is consistent. And here, this is actually not a string, but a file source. So it's very consistent there as well. Perfect. That helped make my world a little bit happier. Great. All right, and now here's what I was talking about, the safe option. There's something called the CVE. And that CVE is like a place where you actually see all of the different vulnerabilities from NIST. And there is one and why this is important. A few years ago in the Ruby's on Rails community, I saw they were really burned by a YAML problem as well. You just gotta be careful to make sure you use safe loading if you are going to load a data, because you don't want to load that data and have a vulnerability that's coming up. And also, well, speaking of the exploit, here's an example of how to do it. If I were to do Python -C and import it, and I were to load a data just like this, I can actually do Python object new OS system, and then whatever I wanted to have an exploit there. So it's very easy to just get access to the system as that user if you aren't using a very careful, safe while instantiating the YAML object. Good. And then the second argument, this is actually because this is a newer version of the library, so it's compatible with PyYaml. The C libraries underneath are very much a little bit older version of YAML. It's slower, but if you use pure of true to get the Python source instantiation, you'll actually get it to be much, it actually works. It's more consistent. It's not as fast, but it's more consistent and modern. And I guess over time, and I would go for consistency right now instead of speed, because we're only talking about text versions of data. We're not talking about something that would be like a gRPC or something that's very binary based. Yeah, this is just a very simple intro for beginners. I have a text data that I want to take that data just like code and inject it over to another system. All right, and we'll quickly go over this as well, depending on how much time we have. All right, same thing. Let's do.
We have a question here.
Yeah, great. Let's jump into that question. I see it now.
Okay.
Are the CFEs seen with the YAML, not seen in JSON because of the format or because of the library implementation? Let's type answer live. Are the CVEs seen with YAML, not seen in JSON because of the format or because of the library implementation? I don't actually know, but I have a great strong guess. So I'm going to put myself out there and tell you the guess. And then someone please correct me if we're wrong, but I do think it's the implementation, but I actually don't know any more than you do. I don't know what it is about YAML that's different than JSON, but JSON is a subset of YAML, or JSON can, these days it's not totally true, but JSON can be represented as YAML. So I believe it just happens to be I don't know. The best I can do is I don't actually know. It's a great question. Either the way it's defined or the implementation, but I believe the implementation in this case, because we see that a safe implementation works. Another great question came in that I'll answer real quick. It's a little ahead of us, unless I just missed it. Sneak is a great way to actually go and lint your code. Sneak, you can actually say, hey, I want to go apply to this to my repo, and it'll go find things for you. And there's also an advisor that comes up, and there's a couple of links that I'll show you if and when we get there, I'll scroll back up and find them, that will actually show you how these things, let's just quickly look at it together. I'll click answer live. Jeff, how are we doing on time?
We're doing fine. Yeah, it's
right,
7:37, I think. We're good.
Great. I'm going to scroll up and show both of these then, because I love interactive questions. It makes it more real.
So we have a few more questions then when you get a chance.
Great. So in this particular case, we see PyYAML, and it has a package score of 81 out of 100. These are the people who do security. That's kind of what they want to do. And they have rated this one as 88 out of 100. And it looks like the biggest reason that's different is maintenance. It's not being maintained very well. This one's very healthy. Hopefully that answers the question. Yeah, Jeff, what's the next one?
So there's a question in the chat. One is it TYP or TYPE equals for that one parameter?
Without the E. And the reason for that, yeah, it's without the E. Yeah, I see that. And if you want to, Raymond, if you put them in that Q&A box, what happens is it's typed, and then people who are looking and searching for this, they'll see it answered, and we click the answer now button, and they would jump to the point in the video where we see it. They wouldn't necessarily see it in chat, but it's TYP, not TYPE. It's not a typo there. That's actually just how it's written, because type is a built-in keyword for Python. Oh, and someone else has just answered. Let me just give a caveat to what we just said a second ago. YK is actually telling everyone JSON has no executable features, and that's why we actually have YAML being a little bit more dangerous than, well, more dangerous than JSON. And that's a great way to say it too. A very clear way of saying it more than I did. JSON doesn't have executable features. Clearly from this exploit that we see above, YAML does. So therefore, if you have those executable features and you expose them, that's going to be great. Thank you. Awesome questions. Any more before we go to the final part of the talk, which is really Jeff's talk. He did almost all this work as I was running out of time going, Jeff, please help me. Any last minute? All right. So the final is going to be XML. And I think this is something we're much more familiar with. And I think it was funny when Jeff was first, when we were first talking about that, Jeff's answer was, yeah, I think I have a little PTSD from when I was doing XML before. So he clearly had experience with it before. And the reason we say that jokingly is that there's a lot of extra fiddly bits to this that have to be done. You know, so we know that XML, most of us have seen XML from a long time ago, it's really just like HTML is cool. Let's make XML, make it like the document, and let's make a standard. And those things were really good, and they actually really changed something. But if we can tell, you know, it's a little harder to use that than JSON, and it's harder to convert back between the two. Oh, sorry, there's a SNYK. I don't see the difference. I think there might be a typo in the text that's being pointed out. I'm not quite sure what that typo is. If someone can help catch that, it looks the same to me. So clearly I still don't see it. Advisor. Yeah, there's something that I don't see it in my even now. Okay, so in XML, thank you. Now I see it. My N and Y's. Yeah, that was me. My N and Y was swapped. So real quick before we jump into XML, those who were confused before, if we actually look at the sneak, the N and Y, and that was me. My fingers have their own subprocessors more than my own brain, and I just probably typed that with the never knowing how it was spelled. So we'll go fix that as well. If someone will help me keep a list of that, that's great. All right, so XML is something we've seen, a little harder, but we can see the same data represented just like this. And if I were to look at a web page, it's very easy to see and represent as a web page. So I can see that there's a person, I can see the first name, I can see the surname. So semantically, it makes sense. It's really bulky. There's a lot of stuff there, but it's not terrible. Well, let's just go on. There's a boilerplate XML at the very first line, which we saw right there. That basically is saying, hey, look, I'm XML. We have a single outermost agent or element. That's the person. So this is basically saying, hey, this is a person object, very much like we see in HTML. We have nested things. Vikash, you raised your hand. Let's go ahead and answer that one. Just a second. 1 second. I see you raised your hand, but I don't see it in the list anymore. There we go. All right, go ahead and ask the question. Talking's permitted. Go ahead and interrupt me when you want. And so, and you probably know a lot more about XML than I do, for sure. And then the address is, notice that the address must be a child of person, since its properties are actually, there are properties there as well. It's not actually just the same thing as strings as we saw before. All right, and there can be more than one phone number. So that's actually a list so that we can actually have more than one phone number. It's just like if you have, hey, look, this is a phone number, this is a phone number, this is a phone number, this is a phone number. We also want to keep it important, just like you see in those systems where it's like, hey, this is my main phone number. This is my office phone number. This is my cell phone number, and have labels. All right, bringing this into XML into Python, just as easy as bringing it in, no question at all. Actually, there are some things that make it easier, but I'm being a little facetious here. Look at all the extra pieces that we have to do. So we're importing the element tree as ET, and then we are actually going to make that a root tree, and then we're actually going to make that root tree a person. And then we're going to, after we have this person dictionary, we're going to basically say, we're going to take each of these keys and build them from the dictionary. So look, here's the first key. Now, could I make this with an open hash and just do all the keys and have these the values? Sure, I could do that too. But we're just showing that each of these things are basically finding the element, pulling out the text, and then assigning it as a value to the dictionary, just like everything else. Because address is a subcomponent, same thing. Finding the address, pulling out the subcomponents, etc.
Oh, one comment. This is Jeff. Mm-hmm. One reason why it's so tedious is that I'm pretty sure that XML tags cannot have spaces in the tag name. So your things like postal space code, I don't think that's a valid tag name if my memory serves me right. It's been a few years.
You're right.
So that makes it a lot more tedious.
You're right, but what I was doing just off, just between like for fun, I was taking the JSON dictionary, and I didn't have time to finish this. I was making new keys for this, where it was actually condensing, taking the white spaces, removing the spaces, adding the value, taking the value out, so dynamically it would match. Oh. And then I was going to use the the part down here that you mentioned. I wasn't going to do that for the examples, but I was just going to use it for creating the source templates that you were using down here. But even that dynamic amount of work is still tedious, and there's a lot of extra meta stuff going on, and it's very confusing. But yeah, I intentionally had preferred space pronouns instead of preferred pronouns. Thank you, Raul. That's funny. So anyhow, I won't go on about how much it's tedious. It's still very, very important. And then when we're done, we're going to dump person, and we can see those examples as well. All right. And so, and Jeff, you had already mentioned this a few moments ago, but there's a mismatch between the XML elements and the Python dictionary list. And we would have to map those up either dynamically through meta or by hand like this. And it looks like what you were saying, Jeff, is that most people prefer this. It's not very popular to do this DECL XML library. I was using it just to generate some data on the outside, even though I was making the examples here. But for some reason, this isn't very popular. Do you know why?
No, I just haven't heard of anyone using that before, and there didn't seem like that was when I did most of my XML stuff, it was in C++, so it's been a few years.
So
no worries.
I can tell you in XML as a structured language, and it was used also in printing, in publishing, as it gave very structured information, a way to transmit it. Exactly. But one of the challenges is, and still there's a number of sources that haven't been converted that had their APIs return XML, which is a little bit challenging, and you have to use the DTD. But it's as you can see, much harder to navigate through it. And there were some programs that helped you to kind of like infer what the structure should be from it. But you can see it's double the weight in transport, because everything is bracketed with name and close name tags, so it's longer. But there is meta information that you can insert into these tags that gave it importance for printing or book publishing as a transport, like a markup language, so that you would know how to render names correctly or different sections of books correctly. But it is good that JSON became the lingua franca of the internet in data transport, because it is so awful in so many ways. But people should know it's still important, because it's still like some systems still serve XML as the API content that you need to get. So
it's quite popular in some systems as well as XML. And to be fair, I think we're all bashing on XML a little bit. To be honest, I am too, because as programmers, we start doing everything else very dynamically, and then we see this and we're like, oh. But to try to look on the bright side, the one thing that I think, and Karen, tell me if you agree with this as well, is that it has an enforced structure. And that it's like almost like a database. Like if you ever have to interact with a relational database with an enforced structure, you can find those referential integrity errors with your data. You can actually have this enforcement, which actually keeps your data clean, whether you want that now up front or down the road.
Right. Actually, the National Library of Medicine it's a document type definition, DTD, for that transport thing. So when you went to submitted articles there, it would have that structure. And you're right, it's a guarantee. You would just have a link in the XML document. This is the reference for the schema that you'd be able to link to. And for JSON, unless you're using JSON schema or something like that, it's referential.
That's not enforced.
Is not necessarily clear.
Yeah, exactly. So it depends on what we're trying to do. If we're trying to do something that needs that structure, XML makes sense. If we're trying to do something where I just want to send this JSON data and it's interpreted and dynamic, then that makes sense. And if you don't know the difference and you had to choose between one, go with JSON. Until you know that you need XML, go with JSON to make your life easier, I think.
Don't use XML.
Or just don't use XML. Fair enough.
There's a couple questions and comments.
I see one of them on the executable features on Yaml. I'll come back to that one in a second. What is the other one?
So there's a comment from Amish saying we use Simple Tree. I guess that's
I would like someone. Yeah, Simple Tree is another library like DexXML, I assume.
think it's a parser.
Parser, okay. Very cool. I'll leave that one answering for a few minutes. We'll come back to that. Well, let's just type simple tree real quick. I think we have a little extra time. Sorry to eat your time up here. All right, simple tree, forest full of trees, simple tree, an efficient open source tool to build tree models. That might not be the same one. That might be like, yeah, this looks like what I do in bioinformatics, the type of, okay. I don't know, we'll come back to that one. I don't know if that might not have helped. So here's an example of what we were talking about a few moments ago about here's defining the structure. And this is just a link off of the Gatkin link that we saw earlier at the bottom of the page. Dictionary had an author, it really should have a name, an integer for a birth year, an array for dictionary, and then more stuff here. So you can have that enforced structure if you need to. But if you don't need that enforced structure, it kind of gets in the way. All right, so I want to summarize. Maybe if Jeff, you think we should or shouldn't, we'll go back over some of the examples really quickly just to show that they exist, depending on the time constraints. But I just want to kind of summarize a couple of things. One, JSON's for programmers. If you're going to use APIs and programmers, JSON's the way to go. YAML's for people, and I didn't say this earlier, and I really should have. I wouldn't try to deal with YAML to load and to export YAML. It's written in the text, but I didn't say it. What I would do for YAML is if I were to use another system that has YAML as an import, I would understand it just enough to know that it is structure. So that if I'm, like, for example, writing an Ansible playbook, but I kind of understand what I'm writing, even though it's an outline, it's easier for me to parse it if I can actually see that, okay, this roles thing that I'm being passed in is really just a list of things. Helps me with the syntax in my brain. And then XML, we've talked about that. It's very stringent, it's useful for some things, and it's still very much a choice for APIs. So you'll see the APIs use this all the time. If you have an option to use JSON, go use that. Otherwise, we'll fall back to XML. Humans, if you're actually putting it in, like basically you're using a system, I wouldn't do your own dumping of YAML. I would actually, as a beginner, I would actually just start consuming it. So serialization is a whole big thing. You know, we just talked about the simpleness from the very beginning. If efficiency, like super millisecond, nanosecond efficiency is not critical, then, you know, I would use JSON. And if you do get into that, maybe you should be talking about a whole different topic, much more advanced on proto-buffers, gRPC. In fact, if you look at the different types of serializations that we didn't talk about, there's a whole list of them. Some of them are still very popular, team message interesting. Some of them have gone by the wayside, you know. Pickle, Python has its own pickle. I didn't talk about that on purpose because pickle is binary and not necessarily compatible with other versions of Python, although we're getting into later versions on supportability that's, you know, changing. But pickle as well, you can actually pickle your Python code directly. But if you're going to share that code with something other servers, you could also use JSON. But you still have the option of just, you know, very efficiently pickle what you're doing and come back to you later. So there's a ton of stuff we didn't talk about. I kept it simple just for the beginners because this is a newbie nugget. All right. Let me quickly just wrap up on questions. Let's hit one of the questions now. So what was simple tree? And here's a link that we can actually try to put this into chat if we can. So looks like simple tree is another very good way of parsing here as well. So very nice. Thank you for that. Another question that came up earlier was, what do I mean by executable features of YAML? I could actually take a function and I could make that function be written out. And that function would actually be code. And so YAML actually could say, I represent that, I could have that be code. And if you see in this example, if I can quickly find it here, give me a second. I have a lot of things on the screen besides this. Oop, I forgot to clean that up. Oops. I will clean. There are a couple of check-ins we're going to have afterwards. Help me on my scrolling. I have a couple of chat windows up here too. I'm looking for the exploit we saw earlier with the CV. Here we go. So look at this particular example. Notice that I'm importing YAML, and then I'm basically going to say, I'm going to use the object new function, like a dunder new, and then I'm going to make that new object, and I'm going to say os.system, and then inside of that system, I'm going to then, very much like doing an os.system call, I could have that represented in YAML, and that could actually operate and do things that is there. Another question that came up, what about the misencoded UTF-8 and JSON exports? At this point, I go, oh, because we start seeing that JSON was a subset of YAML, and then it's not quite anymore. And I don't know if that is or not. And it's one of those things I just kind of skirted around. Does someone else want to take the baton and answer that? Anyone else want to raise their hand and answer it? I'll see if I can grab participants real quick. No? Okay. It's the best I have now is my very official, I don't know, misencoded UTF-8 and JSON exports. I just don't know if I don't know if you're talking about YAML representing the JSON or just the JSON itself. It's a good question. Oh, and I just got another really good feedback. See, look at all the things that you would learn if you did a newbie nugget. All the things you think you know, you're going to learn new things just from getting in front of other people and having them share. It looks like to enforce a JSON schema, there are some Python libraries, and Karen's answering that directly that they're going to look into it. Cool. Oh, and the question earlier, this is like a feedback on the question of, do I mean JSON or YAML? And the question was JSON itself. I don't know. I don't write a lot of emojis or that's not the only thing that's UTF-8, to be fair. My primary language is English. I do have a couple of secondary languages. Most of the character sets I use are almost standard character sets, so I don't have the exploration that could answer that question on different UTF-8 characters that could be seen. For example, different languages or different emojis, those kind of things. So sorry, but great question. If someone knows, let's put them in the comment at the bottom of the YouTube video when that comes out. Or we'll see if we can find somebody else to help answer here. Oh, and another refinement. Not even outside of ASCII, just high. Yeah, I agree, definitely. All right, I don't know, Jeff. We have a choice here. That was most of the newbie nugget. I think we got good engagement from that. I really like it. It looks like we still have another question. Let's ask that one in chat. If you, I don't know if we covered it already, but is it good to know that modern YAML is a superset of YAML and JSON? So yes, we did say that. That is awesome. So it is good to know that, but the YAML that I'm talking about is really the smaller set as a human as an outline because I, as a user, I'm trying to access. Wow, I love this kind of engagement. When I'm in front of a live audience, I liked it as well. It's not quite the same that I'm seeing in chat, but it still gives me that feel of a good engagement and keeps me from being monotone and droning on. Jeff, we have two choices at this point. Oh, good typos too. You guys make PRs. I'll show you how if you don't need to. There's lots of good feedbacks. I will, more PRs to this will be great. Jeff, we can actually quickly go look at those source code or we can wrap it up here. Which do you think we have time for?
Well, I would say maybe at least show where the files are and what they are.
Perfect.
Right.
Let's do that then. Yeah, that's what I meant. Great. All right, so I've just given this in the README of this right here. But if we actually notice that each of these things we talked about, we have demos. So I've just been focused on the README, but there's a from demo right here that actually just says, this is how I read. Just like I said, there's a json.read, but it's an actual demo you could run yourself. All of these things import from an actual source.python. So this is the Python data that we're originally taking. I can ignore this now that I realized that the dictionaries are no longer a sort order problem. That was, I had a problem when I was doing pretty print where I actually thought dictionaries weren't being sorted. That was my mistake. So I'm going to remove this. You only need to worry about this particular piece. And this is just to say, this is the Python dictionary. And if I were to go into, for example, the from JSON, we import that. So we have the data in one place. Loaded data, loaded data, loaded data. So we have it in one place, and then elsewhere, I compile it into all of the different formats that we have here. So that's all this. So basically this file is the source JSON file. And then here we show that we're reading that JSON file. Sorry for the confusion. Let me just make this simple. Here's the JSON file, although this is dynamically generated from the original Python, just to keep it consistent in case I want to change something. And here is the from JSON file that actually go ahead and reads it and prints some things out on the screen. And it shows you that you can use things like normal. Don't forget, I'm a customer in a system, so they're trying to sell me a vacation in Tahiti. All right, so several files here. I would say go play with it, but there's more advanced talk coming. That's a newbie nugget. How many people have encouraged to go give a newbie nugget and talk about something, no matter if you think you have nothing to share? Up, two hands, two hands. I see 2 nuggets. Come on, more people want to give nuggets. Chris is going to give one. I see 4 people who are willing to give a newbie nugget in a future talk. I have 5 people. Great. Keep it coming. Contact Jeff. We would love to see it, but I don't want to bore people. We'll take a quick break, and then we're going to transition to the other speaker.
Well, thanks a lot, Glenn. That was great. And if you want to do a newbie nugget, it doesn't have to be that long.
Yeah. I did a longer one just to kind of get in the details, but newbies are sometimes 5 minutes.
Right.
Oh, can I just say something since I typed click live real quick? Anonymous attendee, converting from YAML to JSON, I would convert, personally, I just convert it to Python because it's what I'm used to, and then dump it to JSON. So I'd make my own library in 3 lines. I would just, take the YAML, convert it to a Python dictionary and back to JSON. Have I been fading out like this the whole time? It looks like I'm fading a little bit.
It's your magical air.
It's getting late. I'm fading. All right. I'm going to stop video. Let someone else go.
Okay.
Cool. Hey, everyone. Thanks for attending this late in your evening. It's really appreciative, especially to BayPiggies team here as well. So again, thank you. What I want to talk about today is an introduction to PyMC3. And it's April 2021 at the BayPiggies meeting. A little bit about me. I'm a data analyst at Autodesk. I'm a teaching fellow at Delta Analytics in my spare time. You can find me at roundingaverage.dev or in the world of Twitter space. I enjoy coffee, learning, and running near the beach. Some side remarks. This presentation does not reflect any of my workings in my day job, and also doesn't reflect I'm not like a core contributor to the PyMC3 project, but just a user. And then also, as we continue to recover from this great pandemic, just please consider helping or contributing to social causes, nonprofits, or sponsoring or advocating for women by POC applicants at your company. Hashtag pay it forward if y'all seen or heard about pay it forward. Pay it forward. Right. Okay, anyways, so we'll be talking about today, PyMC3. Before going into PyMC3, we should lightly talk about Bayesian statistics and Bayesian methodology. What is Bayesian modeling? Just a brief introduction and probability, and then just going and getting started. Thereafter, we're going to talk about the actual library. So what is Bayesian modeling? Well, it's not the Bay, and it's definitely not your Bay, or if you want a Bay, here's a Bay right here, as a joke. But no, Bayesian statistics is a method for statistical inference, which involves at the core like baseline Bayes theorem. We'll talk about a little bit about that later. Is used to update the probability for a hypothesis as more evidence and information is available. The result within typically going through Bayesian statistics is a resulting distribution. And I'll talk about and visualize that later as well. And then coming up here, typically we are taught frequentist statistics in math statistics, where we get some data, we do some calculations by emphasizing like frequency or proportion of data and do things like that in nature. And the resulting information is a single point value or estimate, or think of like, ML modeling, you have a matrix as well, a single point value of values and rows, right? But, coming back to Bayesian statistics, it's a resulting distribution. And then leveraging Bayesian statistics, we can leverage probabilistic programming to create Bayesian models to solve problems that require estimated probabilities. And just lightly, let's go into a brief introduction into probability. A few core principles. Probability values are in the interval of 0 to 1. So 1 being, things are like probably likely. 0, things are probably not likely. And then just decimal values in between, like 0.7, 0.777, things like that, values like that. And then now, then another property of probabilities is things like following the product rule. So for a probability of A and B, that's equal to the probability A given B times probability of B, where A and B is a joint probability between those two variables. And then probability A given B is an expression used to indicate the conditional probability of A given B. And then we also care about independence as well within probabilities as well, and doing the calculations of that. So there are assumptions or principles within probabilities similar to that within frequentist statistics. Another cool thing you should know about Bayesian statistics and like the foundation of going about doing the calculations in Bayesian statistics is this theorem called Bayes' theorem, where we have a probability of some prior given some data. This whole term right here is called a posterior. A posterior outcome is equal to the probability of y given theta. This term right here, it is called the likelihood. This likelihood times the probability of this variable theta is our prior or hypothesis. So our likelihood times our prior divided by the evidence or probability of that y variable to give us a posterior of probability of theta given y. So it's something you should know. And let's go through a straightforward coin toss example. So let's say we have coin toss experiments, and there's different trials for these different experiments. And we want to understand the success of, or particularly, we want to understand the outcome of a probability of the coin toss being heads, or that success of heads. For these experiments, we have, a trial experiment with like no flips at all, experiment with like one flip. And coming down, we have like an instance of an experiment of 32 coin flips for these trials right here. And then we have, maybe, say we don't know what the probability of getting that heads is typically for a coin toss. Let's just imagine we don't know. But we have like maybe some prior belief that that probability could be 0.35, a chance of being heads. And then once we go about into the experiment doing our coin tosses, we get additional data from the added coin tosses in that experiment for like a number of trials. And then we get a likelihood when factoring that data to our prior, right? And then this will create like the calculations for our likelihood. We're not leveraging PyMC3 yet though, but coming down, let's see a visualization representation of these experiments and the trials respectively. There's some variables right here. And then respectively, from the top going down, there's that trial 0 coin flips. And we have our prior right here is pretty flat as a distribution outcome. Right over here is this orange curve right here is our Gaussian or normal distribution. Just comparing visualization side to side too. We have this green section right here was the prior for the tail skewness of the prior distribution. And as we get more experiments with like an increasing number of trials, and hopefully with the hopes of additional heads being the outcome for the growing trials, as we see our distribution changes for our priors and reaches some relation of normality. It doesn't get exactly to normality, but as we go to like a large number of trials, we reach this orange Gaussian distribution. And that's kind of like the abstract idea of what was happening when we factor in like likelihood, prior, and evidence to get the posterior distributions, stuff like single point values. This is a worded description of a visualization, so I'm going to skip this part, but I'll leave that for you. With that being said, you know, I just glossed in the probabilities. There's a lot more to cover, but as textbook authors usually say in like math classes, we leave that up to the reader. So you can do that in your spare time. No, I'm just kidding. No, that word is probably triggering for those that are in academia. It creates a lot of pain. It's okay. I'm here with you. And just kidding. We actually want to go into the procedure implementation of PyMC3 library. Does that sound good? Yes, cool. But you know, just keep in mind that main takeaway, the Bayes theorem, that formula right there. And you know, also don't be a gatekeeper or an elitist in the sense. You know, don't always try to like mention it in the conversations to sound cool. You know, just know it. Say it lightly in conversations. You know, you can handle that communication appropriately. Hopefully. So let's actually get started with the PyMC3 library. So why hasn't Bayesian modeling been a part in an industry-wide recommendation? Similar to the growth of machine learning, artificial intelligence in like the past decades, especially with like the previous AI winter, like decades ago, right? And even like the mentions of an AI winter now, we noticed that at certain times, especially with Bayesian modeling, there's limitations such as maybe computations are quite challenging. The concepts are also challenging to work with the individuals that cannot quite adopt yet. And also the recent advancement of algorithms like Metropolis and the U-turn sampler in the past couple decades. And then also the modernization of technology and advancements of everything data in the past, like, 10 years. A lot of things have been advancing to now have the opportunity to implement probabilistic programming, which is the actual application of going through for Bayesian modeling. Yeah, what is PyMC3? I'll get to it. PyMC3 is a Python package for Bayesian statistical modeling and probabilistic machine learning. It's associated to one of several probabilistic programming languages out there in our data space or in the technology space, which focuses, in this case for PyMC3, on advanced Markov chain, Monte Carlo sampling, and also variational fitting algorithms, and a little bit more to that as well. The continued advancements from the PyMC3 devs or developers, excuse me. Some features of PyMC3 can be the following: intuitive models and specification syntax. Again, leveraging the actual application of these sampling algorithms when implementing and calculating those probabilistic modeling through MCMC or the Monte Carlo Markov chain algorithm. NUTS, which stands for no U-turn sampler, or variational inference, which PyMC3 handles. And just some like historical context, PyMC3 has this feature of depending on the not legacy code base, but a code base that has not been maintained since 2017 through Theorem. Theorem was a AI language or implementation to work with AI, but since then hasn't again been maintained. There's some features to Theorem, like leveraging dynamic C compilation for optimized computation and automatic differentiation. So remember when I said the advancements of technology have provide opportunities for probabilistic programming? This is the case where, like in that, I think 2012 to 2017, where PyMC leveraging that has had its own opportunity to make impact. That being said, PyMC has forked Theorem to own that themselves and rename it and make modifications to make that under the hood framework it's going to be called Sarah as of, probably something wrong, it's Sarah as of 2021. You can check out this article after I send out the link to this slide later on. And there's another note to that. I remember later on. Anyways, let's go to a PyMC3 example. So that coin toss example, let's just go into one of those experiments of n equals 4 trials or coin flip to 4 times. And we still think like, oh yeah, typically for a coin toss, it's about 35% chance that we'll get heads probability. We'd like to see the probability of flipping the coin with keeping in mind our prior assumption, those 4 attempts, and going about and see what the outputted distribution of what that probability would be. And see here, we instantiate some variables right here, and then we use stats models, Bernoulli, and variables to generate an array of that data right there. And so now to go about using PyMC3, which I'm just about to go into, first we're going to instantiate the model object. Secondly, go about doing some inference or calculation that output distribution that I mentioned ad nauseum. And then lastly, do some predictive evaluation and checking some things out very lightly, not going into too detailed anyway. So we're going to import PyMC3 as PM. That's the conventional alias in Python that PyMC3 uses. You can see in case studies and also their tutorials as well. And using a with statement in this context right here, we use PyMC's model class and then create a model. And within there, we're going to assign these variables to the created model for our prior and our likelihood respectively, where our prior, it could be like a different name here and here, but it's good PyMC3 practice to naming the variable and the associated variable within the model right here the same. And for this beta distribution of our prior, and then similarly right here we have a Bernoulli distribution using PyMC's leverage to calculate Bernoulli distributions of what's included in these parameters right here to generate a likelihood. Now, why did I choose a beta and Bernoulli distribution? Well, it comes to the case of just like knowing the problem statement and knowing what to go about within like the calculations you want to get for your posterior distribution. So just keeping that in mind, it's not the implementation of PyMC3 is not a full black box, but it's kind of like a gray box, as Thomas Wiki would say, one of the main PyMC3 authors. So keeping that in mind. So now we're going to do some inference. There's 2 options here. We can go about sampling or variational inference. We're going to use PyMC3's default sampling method, which is called nuts or no U-turn sampler, like I mentioned before. And we're going to create using PyMC's sample operation right here. We're going to do a random draw of 2,000 samples from the posterior distribution to create like this trace object that's associated to our model or coin flip model in this case. And without specifying anything here, we're using that default nuts sampling method. And then we'll talk about a little bit this here later with these parameters right now. So when running that execution, either in script or in a Jupyter notebook, you get this output right here where we're using that default nuts sampler. Use something else, right? But again, we're using the default. And then we get the outputted associated metadata for the draws of that calculations, as we can see down here. Since it's a light sample, it took 19 seconds, but if you're doing something more complex, time may vary at your own discretion. No, or we can also do everything within the same width parameter as we saw in the breakdown, as we previously saw. And we could all do that in one iteration right there as well. Just keeping that in mind. So what did we just do? We instantiated a model called coin flip model, can be named whatever, honestly. And we set our prior and likelihood distributions based on like the idea of like what those distributions are in the context of the problem that we're trying to solve, right? There's some leverage there in working within PyMC3 to produce your results instead of something like a little more straightforward and convenient. Yes, true, but has some flexibility. And then lastly, what we did is use a PyMC's PM sample function to create that trace variable or object with 2000 John samples from the posterior distribution. Now, recall that little parameter return inference data. This is a new implementation that's been added to PyMC3 where for a sample, instead of getting like some defaulted type of data object, we can get an Narvi's inference data object, save it as a trace. We'll check it out what it is under the hood soon, but that allows us to, this inference data object allows us to quickly do accommodation things like quickly see attributes, quickly visualize, and which we'll see in just a moment. Before right here, let's just check, kind of see what's under the hood for this inference data for that trace object, right? So here, if you notice, this inference data object leverages X-ray within Python, just a type object, to storing a lot of information. This is kind of like related to the echoes of our previous talk by our wonderful speaker, Glen from before, about different types of objects. And here, more recently, we're looking at different type of object compared to something like pandas, is where I'm in the data community space, or data frame, pandas data frame is something that's well known. X-ray is another type of data object to store this information and working with it at its convenience. So we have a posterior here, log likelihood, things of that nature. I'll let you all explore that and click through that in your own time. It's very fun just to click around that too. Anyways, not playing around. Let's visualize some things. So now we're going to look into RViz, which is an associated package related to the PyMC3 dev team, what they've implemented to, as a separate package, visualize the data that, or distribution that were provided from the PyMC3 implementation. And we're leveraging that using the inference data object. RViz can use different other types of data objects, but now it can also work with this inference data object that its own honed within it. And just a summary of what RViz is officially. It's a Python package for exploratory analysis of Bayesian models, includes functions like for posterior analysis, data storage, sampling diagnostics, and a lot more. We can plot that trace object through plot underscore trace. RViz has an alias AZ typically, so we're gonna go about that, and we see our visualization right here. To the left is the posterior of that data, which is not pictured right here, probably because of some character issues echoing on my previous conversation about data types, right? There's a little bit error right there. And this is the sampling over time right here and what that's looking like for the probabilities of these samples of the 2000 samples of time. Or maybe we just, want to see a summary table from that trace, kind of in the feel with like a pandas data frame, doing like that describe if you're like not a data, if you're a data person or familiar with the pandas library, you can do RViz.summary of that trace object, get the outputted table right there with the particular mean, standard deviation, and a few other metrics like a high density indicator or interval, and a lot more to that, like an R-hat. And maybe we want to observe the aforementioned summary table as a visualization. We can do that using RViz's plot underscore posterior of that object. to get this little visualization right here. So a summary, what did we go through? We went through Bayesian modeling, the topic of it, brief introduction of probability, and getting started with PyMC3 and working with that, getting like the feel of it, right? However, you know, of course, there's so much more to learn about PyMC3 or any other library. It's the beauty of it. In the meantime, you can learn more about that via the documentation, or you can wait for another exciting BayPiggies meetup. Shout out to Jeff and the team for that. It's to what they said, there's opportunities for future hosting sessions as well. So speak to them if you want to like host a talk as well. You know, with that being said, you know, thank you all, BayPiggies meetup. Y'all been great. Some resources as well. That's pretty much it. Thank you.
Thanks a lot for the great talk. So does anyone have any questions? Yeah, I was going to do, we can clap with the raising hands thing, I guess, but then, so I have one question for you, and or maybe we're getting a question here. Okay, just a clap. So do you use this? And I'm not super familiar with kind of this statistical analysis at this level. And I was curious, how do you use this in your day job? And if so, can you give us a sense of what you do with it?
Yeah, so I don't use it in my day job now, but I will be hopefully in like the next quarter or something like that, as I figure out a way to, you know how it is in like industry, go about and like propose a project, and hopefully it goes into fruition. So I'm considering that as well and playing it out while learning about the library as well. Good question.
Cool. Chris, I think, has a question. Maybe I'll let him talk. That's.
Actually, I had not lowered my hand. I'm sorry, Jeff. Since you asked me, actually, I noticed you, I'll make up a question off the top of my head. I don't know PyMC3, but I've used stats models, and I noticed there was a little bit of overlap with distributions and stuff, but I'm wondering if you could contrast those two libraries a little bit. I don't know PyMC3 at all, other than what you taught us tonight.
Oh yeah, no worries. And what PyMC3 offers is the opportunity to answering a question with like probabilities, super high level, and then going about with those associated outcomes of the distribution of those probabilities, and answering, in my case, soon to be business questions where your stakeholder is like, okay, you know, what's the probability of, you know, that being bad or good based on the resulting outcomes right here, in like frequency statistics, or the typical statistics we're taught in like academia or in school. It's required when doing those calculations and getting like a single value or values, we can, you know, provide the values, but we can interpret our what's like the probability, or getting like an estimation of how confident we feel about that. We can calculate like confidence intervals and things like that, but it doesn't quite answer the particular like business questions of like, okay, if we do this, you know, what's the probability of this and that. That's would
you say that like PyMC3 is maybe more for applications where you're making predictions based on statistics, whereas maybe the other library is more descriptive? Like,
that's a good question. Both can do inference and like descriptive. It's just about like the nature of answering the question and like of the results you want from that. Like, what else can you do from the results of that and the properties to answer the particular question you have? There are I should note, there are other Bayesian probabilistic programming libraries out there, like Stan, which has an equivalent version of PyStan. I think Bambi, and a couple other things I'm probably forgetting, but they're also out there with great communities.
Okay, thank you.
Any more questions? So I'll ask another one while we're waiting. So could you maybe give an example of what kind of question I might answer with this versus using machine learning?
Yeah, that's a great question. We're going about machine learning implementation. We go about going about and like doing forecasting, getting resulting outcomes, and then from there we get like characteristics of like, okay, you know, we got this value, but we can't necessarily provide like a recommendation of like the probability of the outputted like values, but then but we can do that with PyMC3. PyMC3 does machine learning. I don't know what to the extent of how much equivalency it does machine learning to offer its offerings for machine learning to that of another machine learning library that has its core foundations of frequentist statistics or the framework of that type of statistics. But those are the differences there. And coming back again, from what I understand in my own studies, is like it's like one about answering your particular like, business question you want to answer or the question you want to answer, and then for the associated properties after that is like answering the way you want to answer those questions that come up. Hopefully that clarified things.
Thanks.